So when graphing polar equations, first thing I want to do, I want to first check symmetry. Okay, so for the polar axis symmetry, replace theta with negative theta. Okay, so what does this get me? So I get r equals 1 minus sine of negative theta. So this results in 1 minus the negative sine of theta, since sine is odd. So this gives me 1 plus sine theta, which does not equal to 1 minus sine theta, my original. Okay, so the test fails, so the graph may or may not be symmetric with respect to the polar axis. Okay. Now, the next one I'm going to try is the line theta equals pi over 2. And I do this by taking theta and replacing it with pi minus theta. So r equals 1 minus sine of pi minus theta. So this is the difference identity for sine. So this becomes 1 minus, and then in parentheses, sine pi cosine theta minus cosine pi sine theta. Okay, sine of pi, this is 0. Cosine of pi, this is negative 1. Negative 1, negative 1 make a plus 1. So this gives me 1 minus, okay, that's 0 plus sine theta. So this is 1 minus sine theta. Now this is the same. Bingo. So what does that tell me? The graph is symmetric with respect to this line. Theta equals pi over 2. Okay, so it's symmetric with respect to the y-axis. All right. Now, for symmetry, the pole, okay, so origin symmetry, I'm going to replace r with negative r. And so that gets me what? That gets me negative r equals 1 minus sine theta. Okay. And so when I solve for r, I get r equals minus 1 plus sine theta. So the test fails. Let's replace theta by theta plus pi. So r equals 1 minus sine theta plus pi. So this is 1 minus sine theta cosine pi plus cosine pi sine, cosine theta sine pi. So that's 0, this is negative 1. So this gives me 1 minus negative sine theta. Okay, which gets me 1 plus sine theta. And this test fails too, so maybe it's not symmetric with respect to the origin. But we do know it's symmetric with respect to the y-axis rather. Okay, so now what I'm going to do is I'm going to just make a table and I'm going to plot some points. So I've got my table theta, and I've got r equals 1 minus sine of theta. Okay, so if I start working my way through this, let's just do 0. Okay, if I plug in 0 for theta, okay, so I'm starting on my polar axis, okay, at 0. what do I get? I get an r of 1 minus the sine of 0. Sine of 0 is 0, so this is 1. So right here, I got 1 comma 0. Okay? Actually, let me do it like this. So 1, 0, that's fine. Okay, so that's my r theta. So let's bump it up. Let's do pi over 6. I plug in for r, I get 1 minus sine of pi over 6. So that's 1 minus a half, which is 1/2. So at angle of pi over 6, I get a half. So 1/2 comma pi over 6. Okay. And then pi over 4, I get r equals 1 minus sine of pi over 4, which equals 1 minus square root 2 over 2. I typed that in my calculator. 1 minus square root 2, and then divide by 2. That's 0.29. Okay, so we're getting smaller. Okay. Let's bump this up. If I get to pi over 2, what do I get? I get r equals 1 minus sine of pi over 2. So that's equal to 1 minus 1, which is 0. So as soon as my angle's up at 90 degrees, I'm back here at 0. Okay. So my curve is coming in like this. Right? Now, what do I know? I know this is symmetric about this. So I know that I also have these dots over here by symmetry. Okay? So I know I can connect the dots over here. So maybe it would be beneficial for me to start going in the negative theta direction, see what happens. So let's do negative pi over 6 instead of keeping on going this way, because I already know what that's going to be through symmetry. That's why we do symmetry first. So if I plug in a negative pi over 6, I get r equals 1 minus the sine of negative pi over 6, which is equal to 1 minus 1/2, which is 3/2. Okay. So 3/2 is a little bit further out. It's pi over 6, so that's 3/2 comma negative pi over 6. Okay. And then minus, let's do pi over 3, why not? R equals 1 minus sine negative pi over 3. Now this is equal to 1 minus square root 3 over 2. So that's like roughly 1.87. So that's even further out. So that's further away. So this is 1.87 comma negative pi over 3. Okay. Let's do minus pi over 2. And then we'll get symmetry, right? So r equals 1 minus sine of minus pi over 2 was 1 minus 1, which is 2. So this gets me down to 2 right here. So 0, negative, or actually, I'm sorry, 2 comma negative pi over 2. Okay. Now, by symmetry, we know we've got a point over here and a point over here to put this up. Okay. So now we see this kind of looks like a heart, right? And so this type of graph, okay, this type of graph here is called a cardioid. A cardioid graph, okay? So cardioids are of the form r equals a and then 1 plus cosine theta. R equals a and then 1 minus cosine theta. R equals a 1 plus sine theta. And then r equals a 1 minus sine theta. Okay, where a is greater than 0, the graph of the cardioid, the heart, right, passes through the pole. So as you can see here, it passes through my pole right there. Okay?